Hi, welcome back to our electronics course. In this lecture, we will solve another problem. We will analyze another problem for the motion of some charged particle under uniform magnetic field and uniform electric field. This time, the two fields are in opposite directions. B, the magnetic field is in the direction of x, positive x, and the xi, the electric field, is in the direction of minus x. So one in positive x and another one in minus x. Our initial conditions is that at t equal to 0, the particle is at the origin, x equal to y equal to z equal to 0, and the particle has initial velocity in the direction of z, v naught z, and another one in the direction of x, v naught z and v naught x. And there is no initial velocity in the direction of y, v naught y equal to 0. The solution or the analysis will be similar to what we have done before in the previous lectures. We have here force originating from the electric field, the electric force, and another one coming from the magnetic field, the B. So the electric force is equal to Q xi minus x, the charge multiplied by the electric field, and the magnetic force is equal to Q v cross B. Since we don't know yet the motion of this particle, its directions, so we will assume general term for the velocity with three components: Vx, Ax, Vy, Ay, Vz, Ez. Three components, one in x, one in y, and another one in z directions. Cross product B in the direction of x, the magnetic field. The total force applied on that particle is that the addition of these two forces, the vector addition. So F total equal to Fe plus Fm. From the previous lectures, this cross product will generate these two terms, minus Q Vy B Ez plus Q Vz B Ay. And any force is equal to the mass multiplied by the acceleration. In general, the acceleration is in three directions, three components: direction in x, direction in y, direction in z. The acceleration is just the derivative of the velocity with time. So m, the acceleration in the direction of x is dvx by dt in the direction of x. The acceleration in y is dvy by dt ay. The acceleration in z is dvz by dt ez. Now equating the components in the same directions together from this equation and this equation. So in the direction of x, minus q xi will equal to m dvx by dt. These are the two components in x direction, here and here, in this equation and this equation. Integrating this equation will result in Vx equal to minus q xi over m t plus some constant. From the initial condition, at t equal to 0, V in the direction of x is equal to constant equal to V naught x. So at 0, this will be V naught x, this will be 0, plus some constant, so C, the constant is equal to V naught x. This is the velocity equation as a function of t. Integrating this equation will result in the displacement in x direction. So the integration of the x is x, the integration of this term is t squared over 2, the integration of this constant is v naught x t plus some constant. Also from the initial condition, at t equal to 0, x equal to 0. So 0 plus equal to minus 0 plus 0 plus c, so c is equal to 0. So this is the equation as a function, the equation of the velocity as a function of time. This is the equation of the displacement in x as a function of time. Let's go back to this equation. Vx here has two components, two terms. One negative and another one positive. So we have a negative term plus some positive term. So we have subtraction of these two components, of these two terms. At t equal to 0, this will be cancelled because t is equal to 0. So Vx will be equal to V naught x. As t become to increase, this term will increase also. So we'll make some subtraction. This means that the velocity will be less than its value at t equal to 0. So the velocity in x direction is decreasing by time. As the time goes, the velocity will be decreased. So we can expect that at some time, this term here in this equation will be equal to this term. I mean, at some moment, t q xi over m will be equal to v naught x. So at this moment, Vx will be equal to 0. So in the direction of x, the velocity will be decreased until it reaches 0 at some moment. What happened after this moment? After this moment, this term will be larger than this term, v naught x. This means that we will have a negative velocity in the direction of x. Or we can say we will have a motion in negative x direction. And as the time goes on further, this minus term will increase further, so Vx will be increased in the direction of minus x. So in conclusion, the motion along the x-axis is as follows. We have a decreasing velocity in the direction of x, and at some point this velocity will equal to 0, will reach 0. Then the charged particle will go back in the direction of minus x with increasing velocity. Now let's go back to the y and z axis. These two terms, this one and this one. Also by equating the component in the direction of z from this equation and this equation. So we get this equation m dvz by dt equal to minus q vyb. And the equation and equating the component in y direction here and the component in y direction here, will have m dvy by dt equal to q vzb. In the previous two lectures, we know how to solve these two differential equations together. And we can conclude that Vz equal to V naught z cosine omega t, and the displacement in the z direction is equal to V naught z over omega sine omega t, where omega is just equal to qb over m. And the velocity in y direction is equal to V naught z sine omega t, and the displacement in y direction is equal to y minus V naught z equal to minus V naught z over omega cosine omega t. So, from these two equations, we can conclude that the motion of the particle in the yz plane is a circular motion. So we have a circular motion in the yz plane. I mean, if we look from the x-axis and we see the yz plane only, we will see a circle. We will see the particle going along a circular motion. If we look along the x-axis, we see the particle once goes in the direction of positive x with decreasing velocity, and then at some point this velocity will reach 0, and the charged particle will go back from this point along the minus x-axis with increasing velocity. So now we have a helix motion, a helical motion. But we have two helixes. We have a helix with decreasing pitch because the velocity is decreasing in the positive x direction. And we have another helix with increasing pitch, but it goes toward minus x direction or negative x direction. We can describe this using this figure. First, the particle will start its motion from this point. It will